Welcome to This Explainer. We're officially moving way past the days when AI was just some polite little chatbot sitting in a browser tab. We're unpacking a really fascinating new paper today that argues we've entered an entirely new era. AI is now a massive, interconnected execution layer. It's actually reading our intent, diving into software systems, spending compute, and even making real-world purchases, often when we aren't even looking at our screens. And honestly, with this huge leap in capability, we absolutely need strict governance. So let's break down exactly how that works. Here's our roadmap for This Explainer. We're going to trace this major shift from chat to execution, look at Google's unique ecosystem advantage, and track the literal flow of intent. Then we'll talk about what happens when fast agents fail, unpack something called the EP control spine, and finally, look at how we actually govern this whole new agent era. All right, section 1, from chat to execution layer. Let's really look at this fundamental shift. Think about the old era of AI for a second. The whole race was built around a simple chat box, right? You asked a question, a model spat out an answer. The product was just language. It was safe, it was relatively slow, and whatever happened stayed in that box. But the new era? The product isn't just a clever answer anymore. It is a fully operational execution field. We're talking persistent cloud sessions, multi-agent coordination, file operations. Basically, AI taking actions with real-world consequences. It's literally like upgrading from a pocket calculator to a fully autonomous factory. And when an AI can actually do things in the real world, strict control isn't just a nice-to-have. It is absolutely crucial. Moving on to section 2, Google's ecosystem advantage. Let's see how this execution shift turns into a massive strategic play. Here's the thing about the agent era. It is not just about having the absolute smartest model. It's about having the best execution field. Take Google, for example. We really shouldn't look at their ecosystem as just a random collection of apps. According to the paper, this is actually a vertically integrated flow architecture. Think about it. Gmail handles communication, Drive manages knowledge, Calendar controls time, Search handles discovery, YouTube directs attention, Android and Chrome manage the device, and Cloud handles enterprise execution. They control the actual channels where human intention turns into real-world action. That deep integration, it's a huge structural advantage. But man, it also creates a terrifyingly large control problem. Because at the end of the day, the strongest agent is simply the one with the deepest access to your tools and your identity. Okay, section 3, the flow of intent. How does a simple thought actually become an action in a system like this? Let's trace a single command. Say you tell your system, organize a research trip for me. That's step 1, human intent. That vague idea moves to step 2, agent planning, where a whole virtual team of subagents splits up the complex task. Then, step 3 is tool access, hitting booking APIs, calendars, budgeting software. Step 4 is the actual execution. Step 5 is verification, like did it actually book the right hotel? And finally, step 6, the real-world consequence. Your credit card is charged and tickets are bought. Once AI is in this pipeline, the big question completely shifts. We stop asking how smart is the model and start asking who controls this flow from intention to consequence. Which brings us to section 4, when fast agents fail. Because taking the human bottleneck out of this process, that creates some major tension. When humans are out of the loop, high-speed execution can actually be incredibly dangerous. Look, in a chat interface, a slow model just means you're waiting a few extra seconds. But in an execution layer, a fast agent can trigger a cascade of, say, 50 terrible decisions, like buying out an entire supplier's inventory before you can even blink. Speed is a super volatile variable here. Imagine a persistent cloud agent just running in the background and blowing right past your budget. That is real financial loss. Or what if your ambient smart glasses act on something you just mumbled under your breath? Or a commerce agent uses the wrong payment method for a huge enterprise order? These aren't little typos anymore. They are unauthorized purchases and serious real-world errors. So, how do we fix this? That's section 5, the EP control spine. This is the paper's proposed solution to this massive governance problem. The authors call this the energetic paradigm, or EP, control spine. They basically argue that without these specific gates in place, an agent might seem super capable, but the system itself is doomed to become unstable. This blueprint acts as a central spine for the AI. Up at the top, you've got the intent gate to wrangle those vague user requests. Down from there, the planning and tool gates decide exactly what apps the agent is even allowed to touch. Every major step needs a verification gate to prove it actually worked.
There's an escalation gate for when the AI gets confused and needs to ask for help, and a crucial final action gate to stop irreversible mistakes. This spine dictates exactly where action can flow, where it absolutely must stop, and what needs double-checking.
Let's actually map those failure threats from earlier right to their solutions. That runaway cloud budget, blocked instantly by the cost gate, which caps token spend. That unauthorized email the AI drafted, caught by the escalation gate, which kicks it back to a human for approval. A wrong payment selection gets stopped dead in its tracks by the final action gate before the transaction can even clear. And what about a broad, vague instruction trying to set off a huge cascade of weird actions? Reined in by the planning gate. You see, EP control doesn't make an agent less capable. It actually makes that capability usable. It takes raw, risky autonomy and turns it into strictly governed execution. Section 6. Governing the Agent Era. Let's zoom out and look at the whole EP architecture we're going to need moving forward. If we're going to build high-stakes systems, like an AI conducting actual scientific research or running enterprise commerce, we need this complete stack. An agent needs state-space mapping just to understand its environment. It absolutely needs constraint discipline so it doesn't break budgets or company policies. We're talking deductive reasoning, precise energy flow routing to know whether to use the cloud or process locally, and rigorous failure diagnosis to understand exactly why a task failed. This entire stack guarantees that these complex, multi-agent systems are operating under incredibly strict human-agent governance. And that brings us to a pretty stark realization. The real decisive battleground here, it's the control layer. Sure, right now, tech companies are fighting tooth and nail at the model layer, bragging about better reasoning or faster token speeds. And they're fighting at the execution layer, trying to get access to your devices and your workflows. But the true battle, the one that will actually decide who wins the agent era, is at the control layer. It's about who can make this whole execution process auditable, transparent, reversible, and truly aligned with what the user actually wants to do. Which leads right to the paper's main conclusion. Agentic AI is not just a smarter interface. It is an entirely new execution infrastructure. And EP control is what makes that infrastructure governable. Having that full EP analysis makes the system understandable, diagnosable, and strategically safe to use. The thesis is crystal clear. The winner of this AI race isn't necessarily going to be the company holding the smartest model. It's going to be the company that builds the most controllable, cost-aware, and auditable system to actually harness that intelligence. So I want to leave you with this one final thought. As our digital world continues to automate at this crazy speed, and as AI gets more and more tangled up in our calendars, our finances, and our daily workflows, will tomorrow's AI be defined by its raw intelligence or by its governability? It is a question we all need to be seriously asking as we make this massive leap from chat boxes to execution fields. Thanks for joining me for this explainer, and keep questioning the systems being built around us.